Hi, this is Mr. Montoya, your biology teacher, and today we're going to start a new unit, and the lesson for today is focus on an area of biology that we call a classification. And basically what we do is trying to find order in the diversity of life. That's the title of this lesson, finding order in diversity of life. For more than 3.5 millions of years, life on Earth has been constantly changing. The natural selection and other processes have led to a staggering diversity of organisms. And the tropical forests, for example, may support thousands of species to 1 acre of surface. A species, remember, is a population of organisms that share similar characteristics and can breed one another and produce fertile offspring. So biologists have identified and named about 1.5 million of species so far. But they estimate that anywhere between 2 to 100 million additional species have yet to be discovered. So why do we classify? To study this great diversity of organisms, biologists must give each organism a name. Biologists must also attempt to organize those organisms, the living things, into groups that have a biological meaning. To study the diversity of life, biologists use a classification system to name organisms and also to group those organisms in a logical manner. And this discipline that is called taxonomy, which is the equivalent to classification, scientists classified organisms and assign each organism a universally accepted name. One example is the animal that we see in this picture. Depending on where you live, you might recognize this as a mountain lion, a puma, a cougar, or a panther, all of which are common names for the same animal. The scientific name for this animal is Felis concolor. So again, to avoid the confusion caused by regional names, biologists use a classification system to group organisms and logically weighed in a manner to assign those names. So by using a scientific name, biologists can't be certain that everyone is discussing the same organism. When taxonomists classified organisms, they organize them into groups that have biological significance. When you hear the word bird, for example, you immediately form a mental picture of the organism being discussed. A flying animal that has feathers. But science often requires smaller categories as well as larger categories, more general categories. And in a good classification system, organisms placed into a particular group are more similar to each other than they are to organisms in other groups. You use classification systems also, for example, when you refer to, let's say, teachers and mechanics, or be more specifically, biological teachers or auto mechanics. Such a process, like the scientific classification, use accepted names and common criteria to group things. Let's talk about assigning scientific names. By the 18th century, European scientists recognized that referring to organisms by common names was confusing. Common names vary among languages and even among regions within the single country. For example, again, If we look at this animal here, in the United Kingdom, the word buzzard refers to a hawk, whereas in many parts of the United States, buzzard refers to a vulture. So to eliminate such a confusion, scientists agreed to use a single name for each species. 1800 century scientists understood Latin and Greek. They used those languages for scientific names. This practice is still followed by today's scientists, and they use a name in newly discovered species, such as this one that we see here in this picture. This barking deer was recently discovered near the border of Laos and Vietnam. Its scientific name, which is based on Latin, is Muntiacus munjac. So in biological nomenclature, each animal is assigned a two-part scientific name. So let's talk about that. So the early efforts of naming those organisms. The first attempt to a standard scientific name often describe the physical characteristics of a species in great detail. As a result, these names could be 20 words long. For example, the English translation of the scientific name of a particular tree may be oak with deeply divided leaves that have no hairs and their understanding and no teeth around their edges. Long name. This system of naming had another major drawback. It was difficult to standardize the names of organisms because different scientists describe different characteristics. So a major step was taken by Carolus Linnaeus. We see the picture here. He was a Swedish botanist who lived during the 18th century. He developed a two-word naming system called binomial nomenclature. Binomial nomenclature. This system is still in use today. In binomial nomenclature, each species is assigned to a two-part scientific name. The scientific name is always written in italics. The first word is capitalized and the second word is lowercase. For example, the grizzly bear that we see in this picture is called Ursus arctos. The first part of the scientific name, in this case Ursus, is the genus to which the organisms belong. A genus, the plural of that is genera, is a group of closely related species. The genus Ursus contains 5 other kinds of birds, including Ursus maritimus, which is the polar bear. The second part of the scientific name, in this case, Arctos or maritimus, is unique to each species within the genus. Often, this part of the name is Latinized description of some important traits of the organism or an indication of where the organism lives. The Latin word maritimus refers to the sea. Comes from the fact that the polar bear often lives in packed ice that floats on the sea. Let's talk about the Linnaeus system of classification. The Linnaeus classification system is hierarchical, that is, it consists of levels. A Linnaeus hierarchical system of classification includes 7 levels. They are from the smallest to the largest: species, genus, family, order, class, phylum, and kingdom. In taxonomic nomenclature or naming system, each of these levels is called a taxon. The plural of that word is taxa, or taxonomic category. The 2 smallest categories, genus and species, were discussed in the example of the birds. The giant panda, shown in the figure here, resemble the grizzly bear and the polar bear. However, it differs enough from them and other species in the genus Ursus. That is placed in this, so that is placed in its own genus that is called Ailuropoda. Genera that shares the many characteristics such Ursus and Ailuropoda are grouped in a larger category, the family, in this case is Ursidae. These birds, together with 6 other families of animals, such dogs, which is a group called Canidae, and cats, Felidae, are grouped together in the order Carnivora. And order is a broad taxonomy category composed of similar families. The next larger category, the class, is composed of similar orders. For example, the order Carnivora is placed in the class Mammalia, which includes animals that are warm blood, have body hair, and produce milk for their young. Several different classes make up a phylum. The plural of phylum is phyla. A phylum includes many different organisms that nevertheless share important characteristics. The class Mammalia is a group with birds, class Aves, reptiles, class name Reptilia, amphibians, class name Amphibia, and all classes of fishes into the phylum Chordata. All these organisms share important features of their body plan and internal features. Finally, all animals are placed in the kingdom Animalia. The kingdom is the largest and most inclusive of Linnaeus' taxonomic categories. Linnaeus named 2 kingdoms, Animalia and Plantae. And you can see the 7 taxonomic levels here in this picture.